Okay, good afternoon everyone, and you're very welcome to this week's Sustainable Power webinar from Energy Futures Lab. My name is Conor McNally and I'm very pleased to welcome our two speakers today from GE to speak about the company's energy transformation. Ruslan Galimov is a pricing leader for offshore wind in GE Renewable Energy, responsible for leading pricing strategies globally, developing pricing models and the latest market analytics to support GE's product offering in the rapidly growing offshore wind market. He's been with the company since 2011 and before that served as head of the strategic development department with the Bashkir utility in Russia. And we're delighted to say that Ruslan is an alumnus of our very own MSc in Sustainable Energy Futures master's degree program and also has a PhD in economics and management. And joining us from upstate New York, Jim Donohue is the marketing director, marketing insights and promotion for GE Gas Power. He's been involved in the power generation industry for more than 38 years in a variety of technical, commercial, product management and indeed marketing roles. And his expertise spans all areas of power generation. Jim is a mechanical engineer by training. He's been with GE since 1986. And in his current role, he leads a team responsible for gathering and developing customer, competitor and market insights and disseminating them throughout GE's gas power division. So we're delighted to have you both with us and looking forward to both of your perspectives. Just before I hand over to Jim to get us underway, a reminder about how this webinar will work. So our speakers are going to speak for around about 30 minutes and after that there will be an opportunity to ask questions. To do that, submit your questions through the Q&A box which you'll find on the right hand side of your screen. And just remember, this event is being recorded, so if you like you can do that anonymously. So with that, Jim, I'm going to hand over to you and ask you to share your screen so that we can get our presentation underway.
Okay, Connor, thank you. And are you able to see my screen now?
Yes, indeed I can. Thank you.
Okay, thanks everybody for the opportunity to speak with you today. Really appreciate this opportunity. So we're going to kick off by giving you a little bit of a perspective on how GE sees the future of energy. As we're all aware, we're going through some massive transformations within the energy space right now, and GE is an integral part of that transformation. The content we were going to cover today was really take a kind of a global landscape, kind of a view how the power sector is kind of evolving over time, at least as we see it, and as the International Energy Agency sees it as well. We'll talk a little bit about the energy trilemma. And then really how we see coal to gas and renewables, the powerful transition that going from coal to gas and renewables can play in decarbonizing the power sector. And then Ruslan will take over for a little while, talk about renewables, the LCOEs, the levelized cost of electricity perspective of renewables, and then a little bit more about offshore wind. I'll come back on and speak briefly about hydrogen, and then we'll talk about GE's 2030 carbon neutral goal. Okay, so with that, just want to kind of do a little bit of stage setting here with kind of where the world is today. And most of the slides that I'll present really talk on a global basis. I do have a few specific regions, but for the most part, we're talking on a global basis. So you can see roughly 35 gigatons of CO2 emitted globally. The power generation sector being the largest single contributor to those CO2 emissions at roughly 41%, followed by transportation and industry. And then with respect to kind of how that power is being used, currently generating about 27,000 terawatts of electricity. But with that tremendous amount of electricity that's being produced, there are still roughly 770 million people in the world who lack reliable access to electricity, primarily in sub-Saharan Africa, parts of South Asia, Southeast Asia primarily. So still a tremendous number of people without power or access to reliable power. And you know, on top of those people without access to electricity, there's also about 2.5 billion people who lack access to clean cooking fuel. So they're relying on whether it's wood, dung, coal, whatever, for cooking purposes. So again, a tremendous source of CO2 emissions. and really an opportunity to, an example of an opportunity where if we increase electrification of the cooking sector is one simple example, how we can really reduce carbon emissions globally. So we kind of see that, decarbonization of the power sector is key, but there also needs to be electrification of other energy use sectors, because simply put, if the power sector emissions were to be brought to zero, which of course would be an impossibility, but if overnight we were able to bring the power sector emissions down to zero, that would not meet the goals of the Paris Accord. We need to go beyond that, and we need to go quickly, and that's really the focus of our efforts right now. We think of this, the CO2 problem, the CO2 challenge, as really an area under the curve sort of problem. We have to reduce emissions quickly in order to really avoid the catastrophic climate change that we're potentially facing. So one of the, we're a business who's interested in serving our customers, and you can see from this chart just a sampling of some of the customers that we have around the world and kind of their carbon pledges. It's top of mind for them. We see the large utilities and independent power producers are making significant commitments to decarbonization, most of them around the 2050 timeframe. Interesting to note that most of them, quite frankly, don't have a clear path on how to achieve those decarbonization goals. They kind of look at their portfolio, they have some ideas, but to get to carbon neutrality by 2050, they're not quite sure how to do that. And really, technology is going to play a key role in enabling them to achieve those goals. And we see hydrogen and carbon capture and sequestration as clear pathways to help decarbonize the gas sector. And we'll talk some more about that and some of the opportunities that we see to decarbonize gas power. So clearly, the global energy landscape is in the midst of a grand transformation. As Connor mentioned, I've been in the power industry for quite some time. I got my interest in the power sector spawned from the Arab oil embargo back in the 1970s. Quite frankly, I was a teenager at the time, and it was really interesting to see kind of the impact of the Arab oil embargo on the U.S. and people pushing their cars to gas them up at stations and having rationing of oil or gasoline. So that's really what spurred my interest. And I think I can honestly say that there has never been change at the pace and scale that we're seeing today. And that may sound like a trite comment, it's easy to say that, but really I truly believe that having been in this industry for a long time, there's so much attention put on it. You pick up any newspaper, it's top of mind. So it's really a powerful opportunity, quite frankly, to really transform the energy landscape. And we see some kind of key elements to that transformation. The shift towards a more distributed power sector, distributed generation playing more of a role, whether it be rooftop solar, behind the meter, any type of behind the meter generation. But we also see that central generation will continue to play a key role going forward. Again, when you have 750 million people in the world who don't have power or don't have reliable access to power, central generation, we feel, will continue to have a key role. We absolutely see strong renewable growth continuing. There's no question about it. And I'll show some slides that really talk about that and talk to how we see that just a tremendous growth in renewables. And we think that's great. However, we also feel that gas will continue to play a role in the decarbonizing power sector. It'll be a changing role, but we consider that there will be a key role for gas to play going forward. Battery storage, again, great progress in the technology and the cost of battery storage, driven primarily by cost declines supporting the EV space. And we see that there are, as those costs come down, more opportunities arise for applications where that battery storage makes sense. Right now, frequency regulation, as an example, is an area that it does make sense, but that's a very, very small market. Excuse me. As those costs come down, we start to see things like T&D deferral becoming a play. Kind of our view right now where battery storage is that it does make sense for intraday shifting of power. But when you start going to intraday seasonal shifting of power, the economics really start to become challenged. As you're reducing the number of charge and discharge cycles for that system, the costs really start to increase. We see EVs as being the intersection of both the grid, the power and the transportation sectors, and really some great opportunities there. And then digital technologies really, being pervasive and transformative and opening up new business models in the industry. We've gone for, call it 100 years or so in the power industry without having digital technologies, but they do open up just tremendous opportunities. The real key is that each region is at a different point in their energy transformation journey, and how these factors play out will really depend on where those individual regions are in their energy transformation journey. So just a brief discussion about the energy trilemma. Really, these are challenges that our customers and countries are facing every day. The challenge of providing affordable, reliable, and sustainable power for their constituents, whether it's their population. And we really view a mix of technologies as being key to really balancing these three elements of the energy trilemma. And it will, again, vary significantly by region. And these decisions about how to balance these three often competing elements of the energy trilemma will be based on local decisions. And we view that affordable, reliable, and sustainable energy, it's a basic human right. We have a growing middle class in the world that rightly so aspires to better standards of living, and electricity is really fundamental to them achieving those higher standards of living. So just starting to talk a bit about how we kind of see the future of energy playing out. So the chart on the left is what we call our global power outlook. It's an annual process that we do to forecast for the next 10 years. We do a very granular view of power additions, generation, retirements, and it's informed by our global teams. And we basically put that together. But you can see, clearly we see about 3/4 of the capacity additions over the course of the next 10 years being in the renewable space, driven primarily by solar. And you can see that we see gas plants having a role, albeit a smaller role, fossil dropping pretty substantially. But just on the right-hand side, we see wind and solar clearly growing the fastest. LCOE competitiveness is really driving that dynamic. Gas is going to play a vital but changing role. It is dispatchable, affordable, and reliable, and lower CO2 than coal, which is the #1 source of power generation today. We see storage and hybrid emerging and really starting to enable baseload dispatching of renewables. We think nuclear will remain a key source of zero carbon, and we have expectations that small modular reactors will bring costs down significantly in that space. Tying all of this together will be the grid, and the grid is going to will play a critical role in really tying that together and ensuring that as we bring these varied sources into the system, that they are basically tied together and ensuring we have a reliable system. And then again, digital technologies will be tying that all together. So in a nutshell, our view is that we see the accelerated and strategic deployment of renewables and gas power can change the near-term trajectory for climate change, deliver a no-regrets path to reduce CO2 emissions quickly. And that may be a counter to what a lot of folks may think. We love renewables. We think renewables are great, but the pace and scale of renewables deployment just simply isn't enough to decarbonize the power sector at the pace that's needed. So this, I'm shifting gears a little bit here, going over to some IEA, International Energy Agency projections. You can see that the charts on the right-hand side, kind of a progression of electrical capacity over the course of the next 20 years. And this is from the IEA's what they call their stated policy scenario, which is kind of their reference case. It is not the what they call the sustainable development scenario, which is a case that meets the Paris Accord, because they, quite frankly, the IEA does not believe we're on or doesn't believe we're on a path right now to achieve the Paris Agreement. But in any event, you can see, a couple of key points. Today, renewables are about, at least wind and solar, are about 16% combined of the total global capacity. You can see coal is about 28%, gas power about 24%. Going forward, there's not quite a doubling of electrical capacity over the next 20 years, but you can see the tremendous growth in the solar space, where it becomes 27% of installed capacity, wind becoming 14% of installed capacity. Interestingly enough, coal still remains at 14% of installed capacity and gas at 19%. But I think the more interesting story is when you actually consider the generation mix. So again, in 2019, wind and solar PV combined are about 8% of the generation mix of the total 27,000 terawatt hours of generation. Coal still the number one source at 37% of generation, and gas about 23%. And how that evolves, we have tremendous growth. We have about a 50% increase in the amount of generation over the next 20 years. And you can see how wind and solar combined for about 28% of generation, just tremendous increase. Interestingly enough, you see coal still in the mix at 22%. In absolute terms, it's only down about 10%, but on a percentage basis goes down to about 22%, and gas at 21%. One other takeaway from that slide on the right-hand side, that again, according to the IEA and their stated policies reference scenario, in 2040, coal is the number one source of power generation in the world. Okay, the number one single source of power generation. So this is why we feel that really renewables and gas are effective alone at decarbonization at the pace and scale that's really needed to meet the Paris Agreement. This is an example in the US of what we think is a real success story. Now, again, there are some very unique circumstances in the US that were able to drive this dynamic of the power sector CO2 from its peak in 2007 has come down about 33%. When I talk about that unique combination of things, we have a tremendous installed base of coal power, and we're blessed with very, very strong natural gas reserves. So coal during that period went from roughly half of total power generation down, or electricity generation, down to 24%. So basically cut in half. And by the way, all of this occurred while total generation was fairly constant at about 4,300 terawatt hours. Gas nearly doubled from 20% of total generation up to 37%, and wind and solar more than quadrupled, going from 2% to 9%. And so you can see, let me just kind of help you with the graph a little bit. The red line on top is the total CO2 emissions, and you can see kind of how the trajectory that it's been following. So we've had this 33% reduction in CO2, about roughly 30% of that attributable to CO2, attributable to renewables, and about 40% of that really enabled by gas. And the other interesting element is that we've really kind of flipped the dynamic. In the US, the transportation industry had historically been the number one emitter of CO2, and for the past 4 years in a row, the other way around. Power generation had always been the number one source of CO2 generation, or CO2 in the US, and now that dynamic has flipped, and transportation is now the number one source of CO2. So some of the dynamics and opportunities that we see on how gas can help to decarbonize the power sector. So if you look on the left-hand side of this chart, rough numbers, the global average for coal, the CO2 intensity of coal is about 1,000 grams per kilowatt hour. If you just look at the global average of gas, it's that CO2 intensity comes down about 45%, and you got to recognize that a lot of that gas power has been in the ground, been generating for decades, quite frankly. So it's not the most efficient generation sources of gas generation sources we have. GE's HA combined cycle, over 60% efficiency. Basically, those machines are capable of reducing that carbon intensity by about 60%. If we were to burn a mix of 50% hydrogen, 50% natural gas in those HA combined cycle machines, that CO2 intensity would come down roughly 69%. And then if we went to an HA combined cycle with about 90% carbon capture, which is kind of a practical limit of carbon capture, that would come down to 97%. And of course, if we were to burn 100% hydrogen in an HA gas turbine, we would eliminate the CO2 emissions entirely. Key is that some of these technologies are capable today, and some are retrofittable in the future. So as an example, our combined cycle machines today are capable of burning 50% hydrogen. We are working towards getting that up to 100%. So again, as I mentioned earlier, we really see hydrogen and carbon capture and sequestration as viable pathways to low or zero carbon in the power sector. And just another study that GE performed, and really looking at the replacing of baseload coal with a combination of renewables, and we feel that combination of renewables and gas yields a greater carbon reduction than either is capable of alone. So I'll just walk you through this quickly. So let's consider if we had a base-loaded coal power plant, and we were to replace that with wind and solar. Depending on the location and the specific capacity factors, you could probably get a CO2 reduction of about 25 to 45%. If we were to, because the balance of the time, you still need the reliable generation. The balance of the time, the coal power plant would be providing the power. If we were to replace that coal power plant with a combined cycle power plant, again, you can basically match the, you could be dispatching the same amount as the coal power plant. You would be able to reduce the carbon emissions by roughly 50 to 60%. Okay, again, you're basically simply replacing the coal generation with gas generation in that case. And then if you instead took that coal power plant and replaced it with a combination of wind and solar and combined cycle, you would basically dispatch the wind and solar first, and then whenever the wind and solar were not available, you would dispatch the combined cycle power plant. Again, depending on the very specific location, you would achieve anywhere from a 62 to 78% reduction in CO2. And then lastly, if you replace that coal with a combination of wind and solar plus battery to help make that wind and solar more dispatchable and shift some of that excess power, and plus combined cycle gas, we see an opportunity to reduce about 68 to 80% of the CO2 potential. And again, just quoting the IEA, given the time it takes to deploy new renewables and to implement energy efficiency improvements, coal to gas switching represents a potential quick win for emissions reductions. And this is what we view as really key to tackling this decarbonization of the power sector. We need to move more quickly. Again, wind and solar are great. Quite frankly, we're not deploying them at the pace and scale needed, and we need to decarbonize quicker than we are right now. And with that, Ruslan, I'm going to turn it over to you. You're on mute.
Thank you, Jim. Hello, everyone. I'm very glad to talk about GE energy transformation today. And for those who don't know me, I am also SAF alumni, and it's been 10 years I've been graduated from this course, and I'm very pleased to talk about transformation of the energy sector. And we, as a company, GE, we also follow that one. Several times we talk about this topic to Imperial students, and today I'm going to talk about GE Renewable Energy and obviously offshore wind business where I'm working for. So as you see by this slide, you see, I'm sure you've seen this slide many times on your courses already. LCOE, levelized cost of electricity, is really going down. And you see at the onshore wind LCOE is going down from 60 to the prediction of 2025. Solar is going very cheap, and it's going to be one of the most competitive sources of electricity in a nearest future, and it's already happening. So my friends told me that there are some auctions in the Middle East about 20 cents per kilowatt per megawatt hour, which is already a very good price. And you see here that battery storage still remain highs with the lithium-ion technology, and it's costing pretty much the same as building a combined cycle plant. So electricity hour still costs expensive at the storage level. So we see, like, just to give you some scale of what the LCE or tariff we talk about is, I was looking this morning at the EDF bill, and like, you know, this company, right? So if you're looking at the LCE or tariff of the renewable electricity, the tariff is what is 9.7 cents in France, and France is not the most expensive electricity country in the world because we have some nuclear sources in France. And what being said that if we retail price is 9 cents and the renewable sources can achieve the prices from 2 to 4 cents per kilowatt hour, this means that renewable energy really became competitive. And that's why you see a big volume that Jim was talking about of increasing this electricity. And it's going to be going happen again. So in the next slide, you can literally see that offshore wind power in the global energy mix is increasing. And on the left-hand side, you can see that electricity mix can be at 62% of renewables by 2050, which is a huge energy transformation mix. And GE is being part of it. And that's why we have a business in GE called GE Renewable Energy. And it's relatively new business. It was just created in 2015, even though the GE was entering into the wind business in 2002. So now this business is following and driving the technology offering, which is really making this LCE being very competitive. So as you see on the right hand on the slide, so offshore wind starting from 2020, it is going from the range of 40 cents to the range of 35, 40, and that's the projections officially we see across different markets. And the reason why this technology, the cost of electricity is falling is because of technology. And offshore is really right now competing against traditional technologies like coal, combined cycle, and nuclear. And even in some markets, what we see, it's already free subsidy bids. When I joined offshore in 2018, I did not understand the word free subsidy. So now it's a kind of very good word to describe how offshore wind can literally compete against traditional technology without even extra subsidy in that one. And even if you look at on the global aims of the UK, making 40 gigawatts by 2030, the recent tariffs on the auctions was about 30 to 40, let's say, pounds per megawatt hour, and this is going to happen. So this is what you see from this graph. And we will see this development in offshore as an opportunity to relaunch local economies and create post-COVID. And as I'm working in offshore wind, and I can tell you a little bit why it is becoming very competitive. And the answer number one is supply chain and technology. So on the next slide, you can see the offshore wind turbine of GE, which have been investing in this technology. And if you're looking at the right hands on the slide, you see how big it is. It is about the size of the Eiffel Tower or the Chrysler Building. And this is to be installed in the harsh winter conditions into the sea. And in order to do that, you need to implement all the latest achievements in the materials, all the latest achievements of the digital technologies, and in the blades development, because it's just happening right now. We just installed the prototype last year, and turbine size has been doubled in the last 8 years. When I joined in 2018 offshore business, it was 8 to 6 megawatt technology competition landscape. Right now, today, we're talking about 12 to 14 megawatt competitive landscape. And I think that in a few years right now, we will see some bigger surprises and maybe bigger offshore wind turbines. So just to show you the size of this turbine that we are currently talking about is on the next slide, you see that the size of the nacelle, which is like around 500 tons, it's adding a lot of complexities to install it in the sea, but there are some technologies developing. When we launched this machine, it was not very well suitable for some of the vessels, installation vessels in the sea. So right now you see that all the transport industry is following that one. And this is to do what? To reduce the cost of electricity and make the renewable energy and clean energy affordable and sustainable. And I'm glad to be working in GE and being a part of it, because this is a long-term journey and GE is part of this transformation. So just to finish my part of the presentation is we talk about hydrogen as part of the big change. And recently in Holland, there was announced an auction of the offshore wind auction, where you have 1 gigawatt offshore wind farm producing green hydrogen from the offshore wind farm with Shell and Eneco. And in that sense, I'm going to hand back to Jim, who's going to talk about hydrogen and G commitment to the carbon neutrality. Thanks.
Yep. So thanks, Ruslan. So, just a quick slide just to talk a little bit about hydrogen. It's top of mind for many, many people, and it's quite frankly top of mind within our business as well. And different pathways to deliver hydrogen, whether it's blue hydrogen that's using steam methane reforming and carbon capture to produce blue methane, or green, blue hydrogen, or green hydrogen that's produced with electrolysis. At the end of the day, the gas turbine doesn't care where the hydrogen is coming from. It can take hydrogen from either source. And just on the right-hand side, just a little bit about our experience on hydrogen. There's a bit of a misconception that hydrogen is new for gas turbines. We've been burning hydrogen for over 20 years, very, very successful. We have over 6 million hours of operation of our gas turbines on hydrogen and associated fuels. And by associated fuels, we mean low BTU fuels. We have a GE10 machine that's been operating on 100% hydrogen. We have a little bit larger machine, our 6B gas turbines, operating on about a 70% hydrogen natural gas mix. And we are in the process of testing. Our current capability on our HA machines is 50% hydrogen natural gas mix, and we have a clear pathway with what we call our micro mixer combustion system to take that up to 100%. There are some specific technical considerations that need to be addressed, but we clearly see a path to getting to 100% hydrogen probably within the next decade. So with that, just wanted to talk again very briefly about GE's carbon neutral goal. We recently announced that our plans are to have carbon neutrality on our own operations by 2030. It was, you can imagine when we have a very diverse businesses, that was quite a challenge, but we brought all the businesses together and are willing to make that recent pledge. And on the right-hand side, I just want to point out some of the material that's available. Going up to gepower.com, there's a specific hydrogen calculators, hydrogen white papers, and I will say, give you a little bit of a preview. Stay tuned next week. There'll be quite a few announcements by GE, and also some additional material that's available with respect to decarbonizing the power sector. And with that, I'll kind of end with this slide. I think we view GE as being uniquely positioned through its scale, breadth, and technological depth to play a key role in the energy transformation to address climate change. We've been in the energy space since its inception more than 125 years ago. We continue to be committed to this space, and we feel that we really have the opportunity to make key contributions going forward. Okay.
Thank you very much indeed, Jim. That was great. So we'll jump straight into the questions, I think, so that we have plenty of time to take those. And just a reminder to anyone who's watching to submit your questions through the Q&A box, which you'll find on the right-hand side of your screen. So coming to the first question, which comes from Paulina. In the case of replacing coal with a mix of renewables, battery, CCGT, is the CCGT profitable on its own? What about the whole system?
No, I think that the CCGT, again, it varies tremendously by region, but and a key part of that is the fuel prices that you're paying. You know, a typical combined cycle power plant over its lifetime, the fuel costs are typically 60 to 80% of the total cost of ownership. The other two elements being the upfront capex and the maintenance cost. So a huge part of that depends on the market that you're in and the fuel prices that you're paying. But you know, there's no reason to believe that the CCGT would not be profitable. Again, you know, the LCOE that Ruslan put up, you know, there's parts of the world where absolutely the LCOE of wind and solar is lower than a CCGT. That's not universal necessarily. There are some parts of the world. I live in upstate New York. It's a bit of a cloudy day today. There's no wind, so it would be difficult to achieve some of those LCOEs today. You know, that's not to say that if you took it to Saudi Arabia, as Ruslan mentioned, absolutely they could be the wind and solar could be, especially the solar, could be much more cost competitive. So really, those regional differences that I mentioned really factor into the profitability of any of these technologies.
Okay, another question from Paulina, which refers to what you ended your presentation on, and that's the, she asked, what are the technical considerations that need to be addressed so that those gas turbines can operate with 100% hydrogen?
Yeah, great question. And a real key element of that is we believe, well, that gas turbines can be both retrofitted to burn hydrogen and can burn, you know, obviously new units as well can be designed with that. Some of the key considerations. First of all, hydrogen is a much lower calorific value than natural gas. So you need to increase your volume flows pretty substantially to get the same amount of energy to the gas turbine. So as an example of that, you might need larger pipes, simply put, to get the same amount. Once you get to the combustor, the flame speed of hydrogen is much faster than natural gas. So you have to avoid basically what they call blowback, or the flame basically moving back up into the combustion system to where you don't want it to be. Taking it a little bit further downstream, you need to again, because you have larger volume flows, you might need more capacity in your SCR. In other words, to remove the NOx, because as you're burning hydrogen, it has a higher flame temperature, you're producing more NOx, quite frankly. And then if you think of some of the accessory skids, you need, from a safety standpoint, you need the flame basically has a different opacity. So you need to have flame sensors that in the past had been sensitive to natural gas, now have to be sensitive to detecting a hydrogen flame. So those are the types of things, very practical sorts of considerations, not, you know, I won't call it rocket science, just practical considerations. And then one that I didn't mention, just simply the molecule is much smaller, and you have to have where in the past you may have been able to get by with a bolted piping system with natural gas, you may need to go to a welded system, and you may need to change some of your materials, again, to avoid hydrogen embrittlement, because of that smaller molecule side. There are those type of what I'll call practical considerations that you have to think about.
Okay, James asks, are you looking into hydrogen fuel cells to replace the gas turbines? He says he believes fuel cells have a higher efficiency, but correct him if he's wrong.
I don't just doubt that they have a higher efficiency. I think we kind of view the fuel cells as being more appropriate for the transportation space. rather than the power generation space. Just the scale of the fuel cells, and not to say that that won't change in the future, but the scale and the combined cycle power plants compared to the fuel cells are really two different animals, and we kind of view the fuel cells as being more appropriate for those more distributed applications like transportation.
Akanshka asks, and apologies if I've pronounced your name incorrectly. She wants to know what development is going on for carbon capture techniques for coal combustion in the power sector.
Yeah. So really the techniques are not specific necessarily to the whether it's coal or gas or quite frankly a steel mill. The technologies fundamentally are very similar. It does get more challenging simply because in a gas power plant that has a lower density, if you will, of CO2 in the emissions, you're chasing after molecules that are more dispersed than they are in a coal power plant. But fundamentally, the differences are not too different. They're not too different between those technologies. I will say one of the things that we view as a real opportunity is that most of these carbon capture systems require some type of thermal energy to basically separate the CO2 from the sorbent. Somewhere in the carbon capture system, there's a tremendous amount of heat energy that's needed, and we see a real opportunity to integrate. If you have a purpose-built combined cycle power plant with carbon capture, you're able to optimize the thermal loads between the power generation and the carbon capture to really optimize the overall energy efficiency of the entire system.
Okay, a question from an anonymous viewer. Does it make sense to use hydrogen for power generation versus renewables? Would hydrogen not be better for heating and transportation applications?
I'll answer, Ruslan. I take your view. Personal view is we think that absolutely the hydrogen has a at least initially, we believe that hydrogen has a bigger role to play in the transportation sector, in the heating sector, some of the industrial, the hard to electrify industrial sectors. The scale of the hydrogen that's needed for the power sector is immense, quite frankly, and the industry will need to scale up tremendously in order to provide hydrogen at the scale needed to power combined cycle power plants. Not to say that it can't be done, and there are pilots that are being contemplated. We have some in the U.S. There's some over in Europe, but I guess our view is that at least initially, some of the better applications are in the transportation, building, and industrial sectors rather than power. I don't know, Ruslan, anything from your perspective to add to that?
I would like just to say that like 10 years ago, when we were listening lectures in the Energy Futures Lab about hydrogen economy, I see right now it's happening. And right now you have a cheap source of producing hydrogen from renewables, which could be potential solution. So as long as we're going to bring this hydrogen production to the necessary scale, then we can talk about what do we do with this hydrogen, transportation, something. But I think that the key important thing was how to produce it at the scale cheap enough. And it seems to me that there are some line of sight toward that one. And one of the examples of that one is auction won in Netherlands by Shell and Eneco with a commitment to hydrogen. There are some big oil and gas players talking about transforming the hydrogen economy. And here you see also GE is talking about hydrogen. So let's get that one produced cheap, and then you will see that the economy will transform towards a hydrogen economy when it's going to be reaching necessary scale.
Yeah, and I would just add, we kind of view the hydrogen technology today, it's kind of where solar was 20 years ago. And the solar, if you looked at solar technology 20 years ago, you would say it would never make a meaningful contribution to the power sector. And today it is, and it's gonna grow. And there was a lot of technology that that came along. Quite frankly, there were some subsidies that I think appropriate subsidies that really helped to foster that technology development. And with hydrogen, who's to say that those same types of dynamics could play out in the hydrogen space as well? and quite frankly, in the carbon capture space.
Okay, question here from James. How do you see flow batteries storing renewable energy possibly in the future impacting the use of CCGT to do essentially the same thing?
Yeah, I have to admit, I wouldn't consider myself an expert on flow batteries. I think they hold a lot of promise. And as I said during the presentation, we really think that batteries need some type of technology breakthrough to really become affordable for those intraday or interday shifting, day-to-day shifting, week-to-week, season-to-season shifting, that we just don't see the technology for lithium ion getting to that point. But I think that flow batteries might be an opportunity to do that. I don't know, Ruslan, any thoughts that you have?
Just to say that, with this year, we're going to work on the project of forecasting the merchant markets and how weather conditions are affecting the electricity prices. But long story short is indoor market prices become negative of electricity when it's a very highly windy area. So I think that after this research project, we can literally try to show what the future would be. And the future would be either we replace storing the energy by flow batteries or by another technologies, or we run somewhere heavy technology like coal and gas in the background to support the electricity supply and demand. So that's a project which we're going to work on, and I think that we will be able to share these results in a year from now.
Okay, great. An anonymous question. Can you talk a little more about coal repowering considerations? Biomass seems like an attractive solution.
Yeah. So biomass, I don't know. I consider biomass. This may be a personal view more than a business. I'm not a huge fan of biomass as a decarbonization solution, quite frankly. The fact that it's carbon, you can say that it's carbon neutral because obviously, you've captured the trees have captured that CO2 and you're just releasing CO2 that had been captured. I don't think that in the long run that's a solution we have that we can really bank on. There's some examples in the U.S. In the southeast parts of the U.S. where we converted to biomass facilities. And the interesting thing is the transportation, the CO2 emitted due to the transportation far outweighed any benefit of basically having that carbon neutral power generation. So my personal opinion, I think that there are other more meaningful ways to decarbonize than with biomass. I don't know, Ruslan, again, if you have any thoughts on that.
I have only one view that my son is asking me about what is biomass. He's doing the project at school, and I think it will stay remaining as a niche market, and we'll see how it will go. But everything will be driven by the cost of producing it. And so far, what I see, the cost of biomass producing and burning it or whatever doing it still remains pretty much not very, let's say, competitive. So we'll see what goes. But it's going to be staying in the niche market. That's my personal opinion.
Yeah, I would agree with that.
A comment here from Martin, who says, unfortunately, CCS is not going to be attractive for brownfield applications, especially if you have nowhere to transport or store the CO2. Would either of you like to comment on that?
Yeah, that's absolutely a key consideration. There's no question about it. We did a study where we looked at what's called our F-class gas turbines, which are kind of the leading technology, let's say 10 or 15 years ago, and we have a fleet of over about 1,500 F-class gas turbines around the world. And we did a study. We just finished it up about 3 months ago or so, where we simply went to Google Maps and looked at each of the individual power plants and just made a judgment call on whether there was sufficient space around those existing facilities. And again, without consideration of who owns the land adjacent to the facilities, just whether there's space. And I won't get the numbers exactly right, but I think we concluded that there were about 50% that appeared to have sufficient space. There was about another 20% that kind of borderline, and then about roughly a third or so that you're right, there was simply no space to fit a carbon capture facility on an existing brownfield site. So that's clearly one of the challenges that we're going to be facing as we go forward, is how to decarbonize those brownfield sites with CCS, and the space is absolutely a consideration. Now, with respect to the sequestration element of it that you brought up, that's another, we're looking very, very closely at that. What we think that there's an opportunity where if there are clusters of industries, industrial parks, that there can be kind of a critical mass where the infrastructure to transport the CO2 to a storage location makes sense, because again, to Ruslan's point earlier, economics are going to drive this, and you need to get some economies of scale in order to basically get that critical mass of CO2 emissions or CO2 that's been captured to really justify the investment in infrastructure.
Okay, one question here from Raphael. I think we've covered it already, but he's just asking regarding the variability of energy released by the wind turbines and solar panels linked to the weather. What are the options that are potential solutions to overcome these issues? Ruslan, do you want to speak a little bit about that?
Connor, you talk about intermittency, right? Yeah. And this is what literally all the pitch was about, right? It's about that. Like, we have huge amount of volume of renewable energy injected into the existing system. And in order to get absorbed that one, you need to have measures in order to overcome this intermittency. One of the quick solutions that Jim was talking about is using gas power technologies just to sustain CCGT cycle as part of when the wind is not blowing and solar is not shining. Another technology would be a battery storage. Another technology would be some measures trying to force customer to manage their supply, which is a bit more complicated one. But this is, I think, that what's happening right now, having electric car connected and making some consumption profiles slightly shifting towards a way at the moment where the electricity price is cheap. So there's several techniques on that, but what we were trying to talk about is it's a transformation happening. Renewables are growing. You need to have some backup technology, and there is no right answer to it. There are several solutions. One of them is having other technologies like nuclear, gas, or coal run in parallel and a base load, or shifting towards the storage, cheap storage of the energy, or maybe even producing hydrogen.
Okay, I think we're coming close to the end of the session. So Ruslan, I wanted to ask you, just because we'll have some of our MSc students watching us today, and in fact we have our class of 2020 graduating later this afternoon, whether you had any advice for them about going into the industry.
Yeah, I would recommend you to try to get as much of information that you can get during this fantastic year, and because this information you're going to use for the future. 10 years ago, when people were talking about offshore wind, it was kind of a small market, nobody believed to it. 10 years ago, when we were listening about the hydrogen economy, I would say, yeah, about that one. But like you see here that the gigawatts of hydrogen now talking about. So listen, take as much information as you can, and yeah, enjoy this year, because that's going to be one of the best years in your life.
Super. Well, I think that's a good point to draw us to a close. Jim, do you have any final points that you'd like to make?
Yeah, just real quickly, again, thanks everybody for the opportunity to speak with you. I think I can say, especially for the students, that the power industry has been good to me. I think it's a great space to be in. I really encourage you to explore it. There's all different aspects of it. That no matter what your interests are, there's a place in the power industry for you. And then, kind of echoing what Ruslan said, the amount of information that's available, openly available on the web right now. If you go to I use the International Energy Agency just a wealth of information, free information that's available, and I encourage you to really take advantage of that and really educate yourself on some of these what these global international agencies are really saying about the energy transformation.
Super. Well, thank you again to both of you for taking the time to join us today. We really appreciate it, and to all of you who joined us at home as well, thank you very much. And just a reminder that you can find some of our previous Sustainable Power webinars, the recordings of those, on our YouTube channel. And if you'd like to find out more about our upcoming events, including the Dennis Anderson lecture with Chris Stark, Chief Executive of the Climate Change Committee next week, you can find those details on our website, which is imperial.ac.uk/Energy Futures Lab. Thank you very much for joining us. Have a great afternoon.
Thank you, Connor. Thank you, Jim.